You're robbing a house, but you're trying to keep it on the DL. How do you do it with code? This is a Leetcode medium dynamic programming problem that's asked at Apple, Google, Facebook, and many other top tech companies. Here's the problem. You have an array of houses and the amount of loot available in each house. You have to return the maximum amount of loot you can get by robbing these houses, but there's one catch. If you rob two houses next to each other, that is going to alert the police. And the first and last house are actually next to each other because they are in a circular neighborhood. You have to take a dynamic programming approach to solve this problem. And here's the intuition. You are going to calculate the maximum possible loot at every house by taking into account what the maximum possible loot was at the previous house and the one house before it. Here is the solution to the problem. If there are 3 or less houses, you can just rob one of them. Because these houses are arranged in a circular way, we cannot rob the first and the last house, so we create 2 separate arrays. One which doesn't include the last house and the other which doesn't include the first house. And then we return the results from whichever of these arrays gives us the maximum loot. But here's how we go about robbing the houses. We create a DP array of zeros of length houses to store the maximum amount of loot gathered thus far, and we initialize the loot at the first position to be the loot at the first house. We also initialize the loot at the second position to be the maximum of the loot at the first house and the second house, because we cannot be robbing both of these houses together. As we move over the rest of the houses, we are going to be updating our DP array, aka the array that stores the maximum amount of loot gathered so far. And we will update it with either the value of the current house's loot plus the maximum loot gathered 2 houses ago, or the maximum loot gathered 1 house ago, whichever of these 2 values is greater. You will notice this problem has optimal substructure, so we don't have to calculate the maximum value at 2 houses ago or 1 house ago every time. We are using memoized results. And the max amount of loot that we can gather is the value at the last position of our DP array.